Once upon a time, the universe was in complete darkness. At that time, nothing existed. There was no light, no sound, and not even concepts like space and time. But suddenly, a big explosion occurred. An explosion, not like a bomb or any other big or small explosion you know, but an explosion that shaped the laws of physics. The universe was born from nothing. But in those very first moments, something came into existence that has been the building block of everything we can see around us today. I mean, the first elements of the universe. But how did nothing turn into everything? What caused these elements to appear in the first moments after the Big Bang? And how did these elements pave the way for stars, planets, and even us humans? Before I start the video, I wanted to ask you to share our videos with your friends if you like them and introduce us to them. Also, turn on the channel notifications so you get notified of new videos about every day. Alright, let's get back to the topic. Let's delve deeper into this discussion. When the Big Bang occurred, the universe began to expand in an instant, from an incredibly hot and dense point. It's interesting to know that in the first seconds after the Big Bang, known as the Planck era, the universe had a temperature of about 10 to the power of 32 Kelvin. In simpler terms, that's a 1 followed by 32 zeros. Now, to understand how hot this temperature is, I should say that it is more than a trillion times hotter than the surface temperature of the sun. In other words, extremely hot. On the other hand, in these initial moments, the only thing that existed was pure energy. But as the universe cooled down a bit, this energy transformed into the fundamental and elementary particles that make up the structure of matter. Quarks are one of the most fundamental particles of matter. They do not exist separately in nature. Rather, they are always seen combined together in larger particles like protons and neutrons. For example, a proton is composed of 3 quarks, including 1 up quark and 2 down quarks. On the other hand, the binders known as gluons are particles responsible for transmitting the strong nuclear force between quarks. This strong nuclear force binds the quarks together inside protons and neutrons and protects them. In summary, quarks and gluons quickly join together to form the first protons and neutrons. However, there were still no atoms. This was because the universe was so hot that electrons couldn't attach to atomic nuclei. But later, when the temperature reached about 1 billion Kelvin, the first stable atoms in the universe, namely hydrogen, helium, and a small amount of lithium, were born. Now you might ask why only these 3 elements. The reason is related to a process called Big Bang nucleosynthesis, which is scientifically known as Big Bang nucleosynthesis. During this process, only light elements could form. But for the creation of heavier elements, different time and temperature conditions were necessary. But how did these elements create stars? Consider the universe at a moment filled with hydrogen and helium. But this is just the beginning of the story. Under the influence of gravity, these atoms were drawn towards each other, and gradually the first stars of the universe were born. These stars, known as primordial stars, were very large, bright, and hot. However, a major problem they had was that their lifespan was very short. Therefore, these giant stars, after only a few million years, exploded in massive explosions called supernovae. And it was precisely here that heavier elements like carbon, oxygen, nitrogen, iron, and even If we want to divide the world into 3 different eras and see what each era was composed of, first of all, we should start with after the Big Bang. As we can see, at that time, the universe was mostly composed of hydrogen, about 75%, some helium, which is about 25%, and only a very small amount of lithium, approximately 10 to the chi power of -10. Moving forward to the time of the Sun's birth, which was 4.6 billion years ago, there was a slight shift in the abundance of elements. At that time, hydrogen made up 71.6%, helium 27%, and heavy elements 1.4% of the universe. So, some of the hydrogen had been converted into helium, and some heavier elements had been produced. But the third phase relates to 13.8 billion years after the Big Bang, which is today. Currently, the amount of hydrogen in the universe has decreased slightly, helium has increased a bit, and heavy elements now make up 2% of the total matter in the universe. It's interesting to know that because heavier elements still make up only a small part of the universe, the periodic table of the universe is very simple and consists of only 3 elements. Hydrogen is denoted by X, helium by Y, and the rest of the elements by Z, which are referred to as metals even if they aren't actually metals. In astrophysics, you know that in the discussion of the chemical composition of stars, these 3 letters are used. Therefore, with all these elements in the periodic table of nature, it's interesting to know that 98% of all observable matter in the universe is made up of just 2 elements. Hydrogen and helium and all those other 96 natural elements make up only 2% of the observable mass of the universe. But this very 2% has created all the planets, all forms of life, and even us humans, and everything we know. In this regard, Carl Sagan, the famous astronomer, has a well-known saying that we are made of stardust. This means our bodies, the phone we hold in our hands, and the air we breathe are all made from materials that originated from the cores of dead stars. But a challenging question might arise for you. Why is it important to know what elements the universe was composed of at any given time? The reason is that cosmic bodies, especially stars, are formed from the gas that existed at a specific time and place. Therefore, studying the chemical composition of stars and cosmic gases can help us understand how the universe has evolved over time. On the other hand, it's interesting to know that some scientists believe that in the early universe, apart from hydrogen, helium, and lithium, a very small amount of heavier elements might have been created under specific conditions. For instance, some theories suggest that beryllium and boron might have also existed in extremely small quantities during the early stages of the universe. However, another interesting theory about the early elements of the universe is that some physicists believe if physical constants, such as the gravitational constant, had varied slightly, completely different elements might have formed in the early universe, and the world would be entirely different from what we know today. Another group of physicists attributes the early elements of the universe to dark matter. Although dark matter indeed continues to be a mystery, some believe that, in the scientific community, alongside ordinary elements, there might also be a type of dark atoms that we have not yet discovered. Now, what theory exists about dark atoms will be the subject of another video. What do you think? Do you believe that if the conditions of the Big Bang were slightly different, we might not have come into existence at all? Be sure to leave a comment so we can have a lively discussion together. Now, considering what we've discussed, what have we learned? That the universe began with a big explosion that created the first elements of the universe: hydrogen, helium, and a bit of lithium. These elements later, with the help of stars, paved the way for the formation of heavier elements, planets, and even ourselves. Therefore, we are all made from the remnants of dead stars that lived and shone in the universe billions of years ago. And then... So next time you look at the vast and mysterious night sky, remember that perhaps a piece of your existence once shone in the heart of a star.